Assalamualaikum warahmatullahi wabarakatuh and hi everyone. So today we are going to present about vanilla, which is determination of vanillin in vanilla essential oils by using high performance liquid chromatography. Here is my group members starting with me, Nur Atira binti Syari, next Nur Ain Wahida binti Muhammad Khair, Nurul Nadira binti Muhammad Ali, Nur Syamimi Amni binti Rosmayadi, and lastly Nur Atira Natasha binti Muhammad Najri Hilary. For the introduction, what is HPLC? HPLC is high performance liquid chromatography that is described as a chromatographic technique used to separate a mixture of compounds in the field of analytical chemistry, biochemistry, and industry. So the main purpose of using HPLC is for identifying, quantifying, and purifying the individual components of the mixture. There are 5 primary components in HPLC system, which are solver reservoir or multiple reservoir, a high pressure pump, a column, injector system, and the detector. As the experiment is about vanilla, so here is some important things. First, vanilla plants belong to the orchid family with more than 100 species known. For this experiment, we will focus on vanilla planifolia. Second, the main chemical constituent of vanilla is vanillin. And third, there are about 10 polar aromatic flavor compounds that are found in extracts of natural and artificial vanilla flavor. And lastly, among the many volatile aromatic compounds of vanilla extract, vanillin is the most characteristic component of the flavor. There are two objectives in this experiment. First, to analyze vanillin in vanilla extract by HPLC method, and second, to compare the accuracy of the HPLC and spectrophotometric methods in the determination of the vanillin content. So that is all from me. I will pass the next section to my friends. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ain Wahida and I'm going to explain about methodology part in the determination of vanillin in vanilla essential oil by high performance liquid chromatography HPLC. So methodology is basically the specific procedure or technique that used to identify, select, process and analyze information about the topic. Vanilla samples are being cured by 3 methods. First, get boiled in hot water at 65 degrees Celsius for 30 seconds or be dried in the oven at 60 degrees Celsius for 24 hours or drying in the sun for 20 days and 2 to 3 hours every day. So for the steps, firstly, the cured vanilla was fermented and dried in the wind. Therefore, the water content in the cured vanilla will decrease from 55 to 65 to 25 to 30%. So to know if the vanilla samples is dry enough to proceed with the other procedure is, first, vanilla color will be super black or brownish black and shiny. The second one is vanilla will be deflected because water content is low, about 30%. So for the second step is the completed cured vanilla was stored for minimum 2 months. Then the result of the cured vanilla was taken at random for pre-extraction. 10 grams of the whole cured vanilla was measured for the selection extraction and 5 grams for percolation. For the fourth step, the cut cured vanilla in 2.5 cm was weighed about 10 grams for the selection extraction and 5 grams for the percolation. For the extraction procedure, the cured vanilla of the pre-extraction was extracted in the slurry extraction apparatus with 200 ml of the 99.9% ethanol for 16 hours and then transferred to a 250 ml volumetric flask. Next, the flask of the extraction apparatus was rinsed several times with small quantities of 99% ethanol, and the washings was poured into the volumetric flask. Mark up to the mark with the ethanol and mix them well. The cured vanilla of the pre-extraction was extracted in the percolation apparatus or Erlenmeyer and was submerged into 35 ml of 99.9% ethanol of Erlenmeyer, 100 ml for one night, and the solution was then transferred into a 100 ml volumetric flask using a paper filter. The paper filter was rinsed with 5 ml of the 99.9% ethanol and was stored to use at the second filtering. The result of the cured vanilla from the first submerge was pounded in a mortar before the process was repeated for one night. For the ninth step, after being submerged for one night, the ethanol from the second submerge was fused with the ethanol from the first submerge throughout the filtered used paper filter, which is used at the first filtering. The cured vanilla with 99.9% ethanol was rinsed and the washings was poured into volumetric flask. The mark was marked up with the ethanol and mixed well. For the preparation of standard solution, firstly, the standard solution containing 0.5, 1.0, 2.0, 3.0 and 4.0 ppm of each standard was prepared in 99.9% ethanol for HPLC. The solution was stored at 2 degrees Celsius until required for analysis. Standard solution for spectrophotometry containing 1.0, 2.0, 3.0, 4.0 and 5.0 ppm of each standard were prepared in 99.9% ethanol. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Nadira binti Muhammad Ali, and today I would like to present about the result of vanilla content from tough treatment of vanilla sample determined by the HPLC technique and isospectrophometric assay method. For the first treatment, we have X1, Y1 and Z1. The first data show the result of vanilla content by HPLC, which is 2.12%, and by spectrophotometry is 2.48%. Second data, which is X2, Y1, Z1, gain 2.75% by HPLC, while by spectrophotometry is 3.15%. The third result, we gain 2.45 by HPLC and 2.71% by isospectrophotometry from X3, Y1 and Z1. For the fourth data, we gain through X1, Y2, Z1, we gain 3.56% from HPLC and spectrophotometry is 3.89%. Next, X2, Y2, Z1, we gain 3.20% from HPLC and 3.72% from isospectrophotometry. For the sixth data, X3, Y2, Z1, we gain by HPLC is 1.82% and gain 2.20% by spectrophotometry. For seventh data, which is X1, Y1, Z2, HPLC gain 1.22%, while spectrophotometry gain 1.39%. And for eighth data, which is X2, Y1, Z2, we gain 1.12% for HPLC and gain 1.30% by spectrophotometry. The ninth data show that X3, Y1, Z2 gain 1.14% by HPLC and 1.41% by spectrophotometry. For the last data, X1, Y2, Z2, we gain 2.02% from HPLC and gain 2.44% for spectrophotometry. Second last data show that X2, Y2, Z2 gain 2.28% by HPLC and gain 2.86% for spectrophotometry. For the last data, X3Y2Z2 gained 2.14% by HPLC and spectrophotometric gained 2.46. From the result, we can tell that spectrophotometric assay consistently yielded higher value than the HPLC technique.
Hi, I am Nur Syamimi Amni binti Rismayadi, the representative from our group to discuss our findings in this study. The objective of this experiment was to determine vanillin in vanilla using high-performance liquid chromatography. The other objective of this study was also to compare the accuracy of HPLC and isophotometric method. Only compound dissolved in solvent can be analyzed with HPLC. HPLC separates compound dissolved in liquid sample and allow quantitative and quantitative analysis of what component and how much of each component are contained in the sample. Spectrophotometry is a standard and inexpensive technique to measure light absorption or the amount of chemicals in a solution. It uses a light beam which passes through the sample, and each compound in the solution absorbs or transmitting light over a certain wavelength. In this experiment, vanillin in 12 samples of vanilla that were treated in various ways were determined using two different methods, which are high-performance liquid chromatography and spectrophotometric. Various treatment of vanilla will include scalding in hot water, drying in the oven, and drying in the sun, which were aiming to reach one same motive, which is to stop vegetation growth and to chance enzyme format vanilla flavor. For high-performance liquid chromatography, the vanillin was separated on a reverse phase C18 column using methanol acidified water. C18 column are HPLC column that use a C18 substance as the stationary phase. C18 simply means that the molecule contains 18 carbon atom, so that the other atom in the molecule can vary, leading to significantly different substance. Standard solution is a solution containing a precisely known concentration of an element or a substance. The standard solution containing 0.5, 1.0, 2.0, 3.0 and 4.0 ppm of each standard were prepared in 99.9% ethanol. The vanillin were detected at wavelength 280 nanometer. As the experiment was run for two different methods, two data were obtained by the end of the experiment to compare the accuracy between both methods. The first data shows the linear regression equation and correlation coefficient of vanillin and standard for both HPLC and spectrophotometric method. The correlation coefficient for HPLC and spectrophotometric were 0.997 and 0.999 respectively. These indicate positive relationship between vanilla and the standard. In the determination of vanilla content, the data for 12 samples of vanilla with various treatment were analyzed by HPLC and isophotometric were recorded. From the result obtained, we can see that spectrophotometric assay consistently yielded higher values compared to HPLC technique. This is made due to because for spectrophotometry assay method, vanillin was not pure because it was mixed with other substances, and it was absorbed at the same wavelength, which may lead to higher absorption. Even though both HPLC and spectrophotometric use detector UV, the samples in HPLC still go through C18 column and was separated before coming to detector cell, which means only vanillin that was detected in HPLC and may result in smaller analytical result. Even with smaller analytical value in HPLC compared to isophotometric, HPLC still is a more accurate result as it specifically analyzed vanillin in the sample. The usage of UV spectrophotometric can be more accurate if the samples were separated first using special chromatography column. Statistical analysis shows that different treatment of vanilla also affected vanillin content in vanilla for both HPLC and spectrophotometric method. Investigation of the recovery process was carried out using HPLC analysis. Based on the amount of required vanillin standard, the concentration of vanillin standard is 3.5 ppm. In the same condition of measurement, the analytical result using HPLC are 3.49, 3.51, 3.48, 3.48, 3.50, and 3.59 ppm respectively, with an average of 3.49 ppm. Therefore, it can be calculated that the recovery precise obtained is 99.77%. This result shows that the method used to determine the concentration of vanilla using HPLC is valid enough for the next measurement.
Hi, Assalamualaikum. My name is Nur Ati Natasha binti Muhammad Najib Hillary. Next, I will present about conclusion in HPLC. The pre-extraction treatment for cured vanilla slice about 2.5 cm resulted in higher vanillin content because there is direct contact perfectly between vanillin component in vanilla sample and extraction solvent. The vanillin content resulted from the oxidation extraction, which is higher than the percolation extraction. This is occurred because there is continually solvent purity process in the oxidation extraction. Therefore, the density of vanillin content in vanilla extract is high. The HPLC method offers a more accurate means of determining the vanillin content of vanilla than the isospectrophotometric assay, because by HPLC method, vanillin was separated from other compounds. That's all from me, and thank you for watching. Assalamualaikum.